we were at the calcitonin, and we just figured out that it regulates calcium in the blood. Okay, sorry, not calcitonin, parathyroid hormone. Okay, parathyroid hormone regulates calcium in the blood. Now, these two guys, calcitonin and PTH, work together. Okay, so they are produced by two different glands located in fairly same place. Okay, so remember, calcitonin is produced by thyroid gland. Okay, now parathyroid hormone is produced by parathyroid gland. Does that make sense? Two different glands, and they do things opposite of another. So parathyroid hormone that responds, I'm reminding you, to the lower calcium concentration in the blood will stimulate calcium resorption from the bone, taking calcium back from urine, so preventing it from being excreted with urine, and through the activation of vitamin D, increased calcium absorption in the intestine. Is this clear? Now, when you increase calcium concentrations, well, you increase calcium concentrations this way, PTH is not produced anymore, but if calcium levels go above the normal, then calcitonin, produced by thyroid gland, parafollicular cells of thyroid gland, will start to deposit calcium back from the blood into the bone. Does that make sense? So, red is going to be parathyroid hormone, blue is calcitonin. If calcium is low, what's going to happen to PTH levels? They're going to go up. As they go up, what happens to calcium levels? They go up too. They go up too high. Which hormone will elevate? Calcitonin. Again, teeter-totter. Does that make sense? Okay, so that these two hormones, parathyroid and calcitonin, they keep calcium in balance. Now, what do you think? Which hormone has, more profound physiological effect? Which hormone is stronger? PTH, yes. Because getting calcium too high is hard. You can always excrete it with urine. If it goes a little bit too high, you're going to get rid of it through the kidneys. But it falls too low, you're in trouble. Okay? So, now if it falls low acutely, like very large drop in calcium concentration, then the response is going to be quick and profound. But what if you have, well, you, not personally you, but a patient has slightly lowered levels of calcium. Say patient does not have any milk, any dairy products, like does not consume calcium enough. Okay? So if calcium levels go down just a little bit, I can't even show how little are they. A little is changed. So this is normal, okay? You see the normal here? That where the dashed line crosses the x-axis? This is normal. Okay, dashed line crossing the x-axis. See that? If the calcium concentration changes just a little bit, but for a long period of time, the amount of parathyroid hormone will go up incredibly. Actually, it will be comparable, if not more, than in case of acute drop in calcium levels. What it means? It means that if for some reason your calcium in the blood goes down rapidly, PTH will be produced in a large amounts and calcium will return back to normal. But if there is nutritional insufficiency of calcium, and calcium levels in the blood are constantly lower than they should be, PTH will be produced at the very high level. And what it's going to do, it's going to take calcium out of the bones. Does that make sense? And the condition when bones become weak and soft is called osteoporosis, or in extreme case, osteomalacia. When they become almost, literally soft, like soft. Skeleton does not hold the weight of the rest of the body. Okay, it is a really disfiguring disease. Okay, so you see, calcium, dietary calcium is very important. Now, not only this, calcium in the blood is very important. Because what happens in case of hypocalcemia? Remember? Nervous signal doesn't get through properly. So, spasm, muscle spasms, muscle twitching. Okay? And if muscle spasm reaches diaphragm, respiratory arrest, and death. In case of hypercalcemia, the first consequence is a kidney stone. Because a lot of calcium goes through the kidneys into the urine. If it's too high, calcium becomes too concentrated in the urine, precipitates, forms the stones. Unpleasant, but treatable. Muscle weakness and various, pretty much slowing down the nerve transmission. Okay? Depression and constipation. Why is constipation? If muscle weakness is somehow linked to constipation, what gets inhibited? Which muscles? Yeah, smooth muscles in the gastrointestinal tract that just don't propel the digested food. Does that make sense? So calcium is very important in terms of the balance. Now the next gland that we're going to chat about is going to be the adrenal gland. Adrenal. When we say renal, what do we refer to? Kidney. So ad, next to, in this case, look at the second from the left, the gutted modal. If you can see above, yes. So since I'm tethered, but pretty much if you look back here, you see that adrenal gland is located on top of the kidneys. We have two of them. Okay. Adrenal gland, anatomically, if you make a cross section of it, you'll find out that it has two layers. The cortex and the medulla. You will see, we've seen cortex already in some other organ. Brain, yes. Where is cortex? Yeah, outer layer. So generally speaking, cortex is outer layer. And there are several organs that have cortex and medulla. So it's kind of a general name. Outer layer is cortex. Inner is medulla. You will find it in adrenal gland. You'll find it in kidney. Outer layer of kidney is cortex. Inner is medulla. You will find it in lymph node, same. You will find it in thymus, same, okay? Cortex is outside, medulla is inside. We've already discussed the hormones of the adrenal medulla, okay? Epinephrine and norepinephrine. Hormones that are produced in response to the sympathetic stimulation. That's about it, all right? Make sense? So they are water-soluble hormones. They produce from tyrosine. If they are produced in response to sympathetic nervous system stimulation, are they going to be produced fairly fast? Yes. I mean, you can notice it. When you get scared, blood pressure up, pulse is up, all that kind of stuff. Okay. Hormones of the cortex represent, how to say, they also, to some extent, some of them respond to stress, but they respond in different fashion. They don't respond to neural stimulation. They respond to hormonal stimulation. Now, hormones of the cortex are derived from cholesterol. So cholesterol means soluble in lipids, fat soluble. So the receptors for hormones of the adrenal cortex, fat soluble in the cell, right? In the cell, they're going to be in the cytosol or in the nucleus. Receptors for epinephrine and norepinephrine are going to be on the surface of the cell. There are three anatomically distinct layers of the adrenal medulla, adrenal cortex, which I will not ask. So on the, not today, but we're going to get the slide out. It's really hard to tell all those three layers. There are three. You can get the staining. So there's zona glomerulosa, zona fasciculata, and zona reticularis. And three zones that appear pretty similar, to be honest, produce three distinct different sets of hormones. Okay? Very much different. Glomerulosa produces aldosterone, which is responsible for blood pressure regulation, mostly. Zona fasciculata produces glucocorticoids, essentially cortisol. Okay, it regulates your response to long-term stress. You see the difference? That's a short-term stress, and this is a long-term stress response. Okay, and finally, reticularis produces androgens that are kind of secondary hormones. What I mean by secondary, they play part in process of masculinization, process of sexual maturation, but they are not primary players. Make sense? So say in males, testosterone that's produced by testes has way more profound role in masculinization. In females, estrogen that's produced by ovaries has much more profound role than androgens produced by zona reticularis. Does that make sense? So yes, you do have to know the order of zones, and you do have to know which zone produces which hormone. Okay? As I said before, you eat elephant piece by piece. So you can address, okay, we have zona glomerulosa, it produces aldosterone. We'll get to the function later, right? Well, let's chat about aldosterone when we are on it. There's a lot of arrows, but essentially, aldosterone, its immediate effect is the retention of sodium. Right here. We'll get to what causes it. Retention of sodium. Okay? Aldosterone increases sodium reabsorption in kidneys. Does that make sense? So sodium goes back from what's going to be urine back into the blood. Well, the next obvious question is, so what? What follows sodium? Water. Water always follows sodium, right? You move sodium to another fluid compartment, water will follow it. Why? How do we call this process when water goes into the more higher solute concentration? Osmosis, yes. So water will follow sodium by osmosis. Why it's so important? When water moves from urine into the blood. What happens to the blood volume? It goes up. When blood volume goes up, and it's all the same system of blood vessels, what's going to happen to your blood pressure? It's going to go up. That makes sense? So the effect of aldosterone on the blood pressure, it increases it. This effect is temporary, because when your blood volume, how else can you increase blood volume? How else can you get water in the blood? Very, very simple. A lot of you are doing that right now, or not like right now, but have all the devices for it, huh? Drinking water, yes. When you drink more water, what happens? And what happens? Where do you go more often? You pee more, right? So although you increase the blood volume, you're going to get rid of that excessive water by peeing. So, drop in the blood pressure. Let's take a look. Drop in the blood pressure will stimulate the aldosterone release, okay, increased sodium absorption, and increased blood volume and blood pressure. Does that make sense? If volume goes too high, you're going to pee it out. Does that make sense? Terrific. So, quick introduction here. I'm not going to ask about this particular chain of events yet, but it's not direct, so decreased blood pressure is sensed in kidneys, which produce renin, which stimulates production of angiotensin II, which stimulates production of aldosterone. So this is called Renin-Angiotensin-Aldosterone Mechanism, RAA. Okay? Does that make sense? Does anyone remember what else stimulates renin production? Something related to the nervous system. One component of the autonomic nervous system stimulates renin production. Huh? Component like a part of autonomic nervous system. Autonomic nervous system have two parts, which are autonomic, huh? And yes, so sympathetic stimulates renin, right? So sympathetic stimulation will increase your blood pressure. That makes sense? Now, when we say sympathetic stimulation, we usually mean stress, right? Something unpleasant. Fight or flight, or in the long term where you constantly have to fight or flight, it's kind of a stressful lifestyle. So that's your extended stress, okay? That extended stress can stimulate renin. Stress is entirely personal experience, nervous experience. Does that make sense? What is stressful for one person is not stressful for another. Okay? If I end up in Amazonian jungles, I'm gonna poop my pants because it's so stressful for me. For people who live there, it's day-to-day life. They don't really think about it too much. Does that make sense? So, it's a nervous experience. It's in your head. Stress is in your head. That stress, and it is perceived as stress, these nerve impulses act on hypothalamus. Hypothalamus, in response to stress, produce CRH, corticotropin releasing hormone. Okay? You follow me? Now that CRH, that's produced by hypothalamus, so let's make the simplified. So that's our hypothalamus, and this is CRH. Acts on, what's the next down the line? Anterior Pituitary, you got it. So you got Anterior Pituitary, which produces the hormone that students prefer to call ACTH. What another name can you give to it? if CRH is corticotropin releasing hormone, corticotropin releasing hormone acts on the anterior pituitary, and it will produce, in response to corticotropin releasing hormone, it will produce adrenocorticotropic hormone, ACTH. I'm going to write it down. Or we can call it corticotropin. Does that make sense? Corticotropin releasing hormone stimulates corticotropin. Another name for corticotropin is adrenocorticotropic hormone. If you look at this word, you understand why everybody prefers to call it ACTH. 4 letters. It's much shorter than this gigantic word. That makes sense? So ACTH acts on adrenal cortex, which produces, in this case, aldosterone. And aldosterone, what effect of it is going to be? And high blood pressure. So you get, by the way, you get rid of potassium. Those are simultaneous effects. Okay? When your kidneys take in sodium, they also excrete potassium with urine. Kind of go in opposite ways. Does that make sense? Okay. So blood pressure rises. Now, if you're constantly stressed out, what happens to your blood pressure? It goes up and it stays up, right? Because here's the problem. We'll get to the negative feedback when we talk about corticosteroids, but the problem is if stress persists, no hormones can take it away. Does that make sense? If you are under constant stress, actually one of the extremely stressful professions is the stock exchange broker. And I had a privilege not to meet one. No, God forbid. One of my former classmates, she worked at a stock exchange. Not as a broker, she was like an IT specialist, but she met several. And she said that, yeah, they retire in like 4 years with the buttload of money, and they sick. They have like every possible disease, like hypertension, diabetes, and all kinds of stuff, because of the nervous and lifestyle with not a lot of movement around. So it's kind of a double-edged sword. Okay, does that make sense? Not about stock exchange, but about aldosterone. Now this, you may ask, what does that illustrate? So here you have arterial pressure. When you apply aldosterone, arterial pressure goes up. Now, if you would look at the volume of extracellular fluid, it goes up. If you would look at the sodium excretion, it initially goes very much down. That's why the volume goes up. Does that make sense? And then you continue normal sodium excretion because it's a temporary effect. When your blood pressure is normal, aldosterone has stopped being produced. Okay? Any questions on aldosterone? This axis that we pictured here, it's the part of what's called hypothalamus pituitary adrenal axis. Okay? Make sense? All right. We have about 30 minutes.